Now let's take a look at a second example of a hyperbola. In this one, our equation is set equal to 144. So we want to divide everything by 144. So then I get x squared over 4 minus y squared over 36 is equal to 1. In this problem, the x squared is positive, which means my vertices are going to sit on the x-axis instead of the y-axis. Again, it doesn't matter which number is bigger, a squared or b squared. It matters which variable is positive, x squared or y squared. So again, I'm going to start off by making my box. I'm going to travel to the left and to the right 2, and I'm going to travel up and down 6. And I'm going to draw my box in first. The reason I'm going to draw my box is because then I can go ahead and draw my asymptotes, which have to be done first before I can plug my parabola in. So we went forward 2 and backwards 2 because 4 was underneath the x, and I went up and down 6 because 36 was under the y. Once I get my box drawn in and I draw my asymptotes, I can then go ahead and put my curve in. Notice that with these asymptotes, I get a very wide curve instead of one that's thinner. After I draw my asymptotes and draw my hyperbola, I can also identify my vertices as plus or minus 2, 0, and I want to identify my foci. For our hyperbola, c squared is equal to a squared plus b squared. And so when we plug in our 4 and 36, we get that c squared is equal to 40, take the square root of both sides, and we get c is equal to 2 plus or minus radical 10, which is about 6.3. So to graph, I'm going to go from the origin forward 6.3 and backwards 6.3. If I need the equation of my asymptotes, remember that again the equation of a line is y equals mx plus b. For all of these, they're centered at 0, 0. So my b, my y-intercept is 0. And to find my slope, I'm going to start at the origin, and I'm going to go up 6 over 2, and that will reduce down to a slope of 3. So we get the equation y equals plus or minus 3x. If we're given information about our ellipse and we want to come up with the equation, just like for, not our ellipse, our hyperbola. Just like for the ellipse and for our parabola, I always make a sketch so that I know which equation to use. So in this case, my foci are plus or minus 8, 0, and my vertices are plus or minus 2 radical 3, 0. So if both my vertices and my foci are on the x-axis, that means my equation is going to be x squared over a squared minus y squared over b squared is equal to 1. I can then go ahead and find my b using c squared is equal to a squared plus b squared. We end up with a b squared of 52, and then we can write our equation. For my next one, we're given that the foci are 0 plus or minus radical 34 and 0 plus or minus 5. This time, since my vertices and foci are on the y-axis, my equation is y squared over a squared minus x squared over b squared is equal to 1. We know that a is the distance from my center out to my vertex, and c is the distance from my center out to my focus. I can use this information once again to find my b by using c squared is equal to a squared plus b squared for our ellipse. And we finally get the equation that y squared is y squared over 25 minus x squared over 9 is equal to 1.